name is Pallavi Pave, and today I will be talking about Raman spectroscopy. Now, I know the first thing running through your mind is, does this have anything to do with ramen noodles? Unfortunately, no it does not, but you can grab a cup of noodles while watching this video. So, what exactly is Raman spectroscopy? It is a technique used to identify any solid, liquid, or gaseous material. It is based on a complex phenomenon called the Raman effect. When a substance is exposed to a laser light, the photons, or light particles, are absorbed by the substance. The photon excites an electron in the substance to a higher energy level, and when the electron decays back to its original level, a scattered photon is released. Most of the scattered photons have the same energy, frequency, and wavelength as the original or incident photons. This is known as the Rayleigh scatter. A small percentage of the photons, however, are inelastically scattered. This means that the frequency and consequently the wavelength of these scattered photons are different from the incident ones. This shift in frequency is what is known as the Raman effect, and it is unique to each substance and therefore can be used as a fingerprint to identify specific materials. So, now that we have many scattered photons, how do we separate the Rayleigh scatter from the Raman signal? The main challenge is that there are very few photons that are inelastically scattered compared to the ones that are part of the Rayleigh scatter. The good thing is that it is possible to get rid of the Rayleigh scattered photons. Since the Rayleigh scattered photons have the same wavelength as the original light or laser source used, we can filter the wavelengths that are very close to that original source. This will allow Raman scattering to be seen more easily. So, are you guys following me so far? The next thing to do is identify the substance by comparing its Raman signal to the Raman signals of a list of materials in a database. So I've told you what Raman spectroscopy is, but why did I tell you this? What are its applications? One device that uses Raman spectroscopy helps emergency responders and law enforcement officials by detecting explosive threats and identifying narcotics, illegal drugs, and hazardous materials. Another device can even identify the raw materials of pharmaceutical and cosmetic ingredients. And finally, a potential beneficial usage for Raman spectroscopy is to use it to create a device that can identify allergens in foods so that the millions of people around the world with food allergies don't ever have to worry about eating something that contains an allergen again. Thank you for watching my video on Raman spectroscopy.